Section 3.2, Logarithmic Functions, Examples 4 and 5 on using properties of logarithms and inverse logarithms. Okay, here we have a couple of basic log properties involving the number 1 that might be important to know. The first says log base b of b equals 1. I mean, that makes sense. If we rewrite this in exponential form, that would be b to the first equals b. And we all recognize that. The second basic property is that log base b of 1 equals 0. If you change this into exponential form, that would be written as b to the 0 power equals 1. And anything, with the exception of 0, raised to the 0 power will always equal 1. So example 4, we're asked to evaluate log base 9 of 9. Well, let's say that equals x. And so if you think 9 to the x equals 9, oh, it's just that first property we just reviewed. And so we realize that this certainly is going to equal 1. Okay, next we're asked to evaluate log base 8 of 1. Let's say that equals y. So if I rewrite this in exponential form, that would be 8 to the y equals 1. Oh, this is just a second property we just looked at. And we remember, oh gosh, back from Algebra 1, that anything to the 0 power equals 1. So we're going to say y in this case equals 0, because remember, 8 to the 0 power equals 1. Next, let's take a look at the inverse properties of logarithms. For values of b greater than 0, where b is not equal to 1, we can say log base b of b raised to the x power equals x. Now that might look a little confusing. So, think about it. If we rewrote that in exponential form, that would be written as b to the x equals b to the x. Oh, makes a lot more sense when we look at it that way. Now let's take a look at this expression right here. B raised to the power of log base b of x equals x. Looks a little confusing. So let's take it from exponential form and rewrite it in log form. Wouldn't that be log base b of x equals log base b of x? Oh yeah, now that you write it that way, certainly they're equal. Okay, so in example 5, we're going to use those two properties we just took a look at. First, evaluate log base 7 of 7 to the 8th. Well, if you rewrite that in exponential form, let's say it equals x, we would then say 7 to the x power equals 7 to the 8th. Well, then it's really easy to see that in this instance, x is going to equal 8. And this is using that first inverse property we just took a look at. The next is written in exponential form. So we've got 3 raised to the log base 3 of 17th power equals, oh, let's say y. So if I rewrite this in log form, that would be log base 3 of y equals log base 3 of 17. Well, now that I take a look, it's really easy to see that y must equal 17.